Hello. This is a very quick introduction to Pure Data for MUS 355 2019-2020, and I'm going to set myself a task of making a base 10 to base 2 converter. Although I could use Pure Data for this, I'm actually going to use Per Data because I will have just been using it to demonstrate the USSS toolkit. So I launch Per Data. I don't need to worry about sorting out sound drives because I'm not going to make any sound here, but I am going to make a file new. I'm going to save that and put that in my temp folder and call this base 10 to base 2. So base 10 is the 1, 10s, hundreds, thousands that we know and use every day. Base 2 is the language of computers, and it's 1s, 2s, 4s, 8s, 16, 32, 64, 128, 256, 512, 1024, 2048. I've been doing this a long time. Get to know your base 2. It's very useful because these 1s, 2s, 4s, 8s are bits, binary digits. And so when you see in Cubase it says, do you want a 16-bit or a 24-bit file? You'll know that this is how the numbers of sound are made up. So PD, we tend to put various things on the background here, join them up, and then get out of edit mode and go into play mode to run our program. I'm going to put two objects that will do two mathematical divisions, or two different types of division. I will also up the font size for you, font size to 16, and I'm going to type mod space 10. I'm going to put an object box and I'm going to type div space 10. So div is the division and mod is the modulus. In short, this is what we used to have at school when you divided 8 by 5. It gave you 1 5, remainder 3. So I'm going to try and emulate that. I'll put a number that goes into both left-hand inputs of the mod and the div. The right-hand input in these instances would be to change this number. So bear that in mind. And then I'm going to put another number box at the output of a mod. And what's really useful is if you highlight the box you want and then put a number, it joins it up for you. So that's our program. Save that, get out of edit mode, scroll through here, and you see that before I get to mod 10, this is 0, 1, 2, 3, 4, 5. So 5 divided by 10 is 0, remainder 5. So actually what I want to do is just swap these around so it feels logical. So do you get what's happening? We're actually seeing the number here, but split up into the number of 10s and the number of 1s. So 46 is made up of 4 10s and 6 1s. And we can get as far as 99 before this program goes wrong. So to convert to base 2, we need to think about our number sequences. And these would be 1s, 2s, 4s, etc. So let's say we're going to have a number between 0 and 128, maybe 256. So let's go to 128. If this is my number of 128s and this is anything left over. So until I'm up to 128, this is going to give me 0 to 128. So the next one I want is a modern div sequence. So we can just copy the sequence and duplicate that, so that the output of here is now divided by 64 and 64. Oops. Come on, little fella. So let's stretch this out a little bit. That should be enough. 64 32s, all our 32s, and left over 16s. Our 8s, our 4s, and our 2s. And we'll see, this might be what we need to finish with. So this, our leftovers come into here, our leftovers come into here, our leftovers come into here. Oops. Oh, come on. Our leftovers come into here. Our leftovers come into here. Now let's see what happens. So if we start from 1, and we go up to 2, you can see that there are 0s and 1s here. So these are the boxes we want to show, telling us how many 128s, how many 64s, how many 32s. And we finally want to show this one as well, which is just the remainder, which will be our 1s. So let's go back to 0 again. 1. 0, 0, 0, 0, 0, 0, 1. So we've made a 1, 2, 3, 4, 5, 6, 7, and 8-bit number. 2 is, this is our 2s, 1, 2. 3 will be 1, 2, and a leftover. 4, we'll now have a 4 and 2 zeros. Working out. Let's do something a bit more adventurous. Let's do 33. So it's 132 and a 1. Let's do something 1 less. Let's do 31. No 32s, but a 16, an 8, a 4, a 2, and a 1. Good to go.